question, I expect you to ask, how can I find position or location of my data? So, when we talk about variation, we can talk about the position or location of data. Or we can say that how many percent of our data are located between two values in the collection. So today we're going to talk about z-score and also empirical rule. Z-score and empirical rule. Okay, let's talk about empirical rule first, then we switch to z-score. Empirical rule says, first note that we need to have a condition to use this rule. If the data, the pattern in our data is normal, remember yesterday we talked about the normal distribution, bell-shaped graph. If we have a normal distribution like this, normal distribution, bell curve. Remember that when we talked about bell curve, we say that, hey, mean, mode, and median are the same. This is the center. So the center, mean, mode, or median. We can actually divide this line into separate pieces using standard deviation. So, on the right-hand side of the center, suppose the center or the mean is mu. On the right-hand side of mu, you can scale it to 1 standard deviation. So this number here is mu plus 1 standard deviation. The next scale is mu plus 2 standard deviations and mu or the mean plus 3 standard deviation. On the left-hand side, we can do the subtraction. Mean minus 1 standard deviation, mean minus 2 standard deviations, and mean minus 3 standard deviation. Okay, let me write down one example on the right-hand side so you understand what's going on here.
So I have a question. And how did you know that is the left side and right side?
So I'm giving you one example to actually see what do I mean by this. Suppose you have a normal distribution. Suppose we have a normal distribution. What is given? Mean is given as 64.2 and standard deviation is given as, let me see, my standard deviation is 2.9. 2.9. Construct your normal distribution. Construct the graph. Okay, so I know that I haven't finished this rule. I'm just writing the horizontal axis, the numbers here. So since I have a normal distribution, I have a line and I have a bell-shaped graph. Okay. On this bell-shaped graph, on the horizontal axis, my center is in the middle. I know that. Since it's a normal distribution, bell-shaped graph, my mean for the center is in the middle, 64.2. Now, I'm going to use my standard deviation to find the rest of these numbers. Next number is 64.2 minus 1 standard deviation, 2.9. I have to do the algebra, do the calculation. My next number is 64.2, so plus 2 times 2.9. And my last number on the right-hand side is mean 64.2 plus 3 standard deviation. 3 times 2.9. On its left-hand side, however, I have to do the subtraction. So I get 64.2 minus 1 standard deviation. Then I get 64.2 minus 2 standard deviations. And the last number is mean minus 3 standard deviations. Okay? There we go. Let us find these numbers here. You get 67.1. So this is 67.1. Then you get 70. And my last number is 72.1. On the left-hand side, I get 61.3. 61.3. Then I have 58.4. And my last number is 55.5. Okay, perfect. So, what does this rule tell us? This rule says if we have a normal distribution, then 68% of the data, 68% of your data is between 1 standard deviation of the mean. So 68%. 68% of the collection of the data are in between 1 standard deviation. 1 standard deviation on the left-hand side, 1 standard deviation on the right-hand side. So, take a look at your example. You can say that, hey, since I have normal distribution, 68% of the collection for sure is between 61.3 and 67.4. 68%. It means that more than 50% of your data are in between these two numbers. This rule says 95% of your collection, 95% of the collection are in between 2 standard deviations away from the mean. 95%. So 95% are in between 2 standard deviations away from the mean. They are spread out. 95% of your data are spread out between 2 standard deviations away from the mean. Also, this rule says 99.7% of your data are between 3 standard deviations away from the mean. 99.7. Almost the majority of the data are in between 3 standard deviations away from the mean. Almost all of them. There you go. So let's write down empirical rule here. I give you one example to make sense of it. Empirical rule. So it says very well, if you have a bell-shaped graph, a normal distribution, the mean is here. Suppose this is mu. Then here you have mu plus 1 standard deviation, mu plus 2 standard deviation, mu plus 3 standard deviation, and on the left-hand side, mean minus 1 standard deviation, mean minus 2 standard deviation, and here you get mean minus 3 standard deviations. Okay, so remember that 68% of your collection are in between 1 standard deviation away from the mean, 68%. Then you have how many percent? 95%. 95%. Let me use a different color for you. 95%. 2 standard deviations. And 99.7 in between 3 standard deviations. 99.7. Between 3 standard deviations. So I expect you to ask, how about I just divide this into smaller portions? Why not? Take a look at this. I'm just using the exact same graph for simplicity. Here you have your mean plus 1 standard deviation, mean plus 2 standard deviations, and mean plus 3 standard deviations. So make sure the scale is correct. And on the left-hand side, mean minus 1 standard deviations, mean minus 2 standard deviations, and mean minus 3 standard deviations. Okay, so this is my mean. All right, this is my mean. I'm using this vertical line to just divide this into 50%, 50%. Okay, so I have 68% covering the middle part. 68% divided by 2 gives you 68% divided by 2. Here you can get so 68%, 68 divided by 2, we get 34. 34% on this side, 34% on this side. 68% is the middle one, so we can divide it into 2 pieces. Very well. So for the rest of it, we get 13.5%, 13.5%, and if you add all of these portions together, it must add up to 50. So if you add these two, we get 47.5. So 47.5, and you have 50%. So you get 2.5% on each side. So this is equivalent to writing these in smaller portions. So 34%, 34%, 13.5%, 13.5%, 2.5%, 2.5%. Why I want this? Because it helps me to answer a question easily. So take a look at one example. I have 1 million students. The result of an exam, or the final exam, is mean equals to 75 and the standard deviation 5 points. So somebody asked me, how many percent of your students got a score 70 to 80? How many percent of students got 70 to 80. Another question. How many percent of students got 80 to 85? C. How many percent of students got lower than 65? Okay, since I have 1 million students, and suppose I know it follows a normal distribution, I can use empirical rule to answer these questions without doing any specific calculation. So how many students got 70 to 80? So mean is 75, mean is 75. One standard deviation above gives me 80, one standard deviation below gives me 70. So one standard deviation, empirical rule says it is just 68%. 68% of my students, which is equivalent to 680,000 students. Okay, this is a good result. It's not that bad. How many percent of students got 80 to 85? 80 to 85. So 80, 85. Where is this piece? This piece is actually here. 80 to 85. 13.5%. 13.5%. So it means that we have 13.5% of 1 million. So you get 1 0 here. We can cancel out 3 zeros and 3 zeros. 135,000 students got 80 to 85. That's very good. I'm so happy about it. That's a good result. That's a good news. And finally, how many percent got lower than 65? 65. So the mean is here 70, 75, one standard deviation, 70, and two standard deviations is going to be 65. So it's going to be lower than 65. Here, 2.5% got lower than 65. 2.5% failed the exam. 2.5%, 2.5% of 1 million. 2.5, we took this decimal as a 0 down here, cancel out 3 zeros, 3 zeros, 25,000 students. Very well. Let us take a look at our last page on 2.4. Here we go. Question says, using the empirical rule. In a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64.2 inches. So this is your mean, guys. Take a look at the keyword mean. With a sample standard deviation, which is 2.9 inches. Question says, estimate the percent of women whose height are between 58.4 inches and 64.9 inches. Let us solve this example together. So we are on page 5, last page on 2.4. And remember that we have a nice rule. We remember these numbers, and we're going to use these numbers to have the approximation or estimation. So in this example, the information given to us, we know these information. We have a normal distribution. So we can follow the empirical rule. So we can use the empirical rule. That's for that. Also, we know that the mean of the sample is equal to 64.2 inches, and standard deviation is equal to 2.9 inches. Okay, since we have this information, let us actually construct the normal distribution graph. This is our mean, 64.2. One standard deviation, 64.2 minus 2.9. 64.2 minus 2 times 2.9, and 64.2, I'm sorry, this is plus 3 times 2.9. And on the left-hand side, we start subtracting. 64.2 plus 2.9, subtraction. I think I'm just a little tight. There we go. 64.2 minus 2 times 2.9, and finally we have 64.2 minus 3 times 2.9. So we are using actually the empirical rule to write these numbers and answer the question. Question says, how many percent are in between 58.4 and 64.2. Okay, 64.2 is already here. So I'm going to just circle that, and I'm going to do the calculation to write down the rest of the numbers. Okay, 64.2 plus 2.9 actually gives you, let me see, 67.1. So since it says 58.4, I have to go to the left-hand side, not to the right-hand side. So if you do the calculation here, you get 61.3. And here, if you do the calculation, we're going to subtract 2.9 from 61.3. It's going to be 58.4. Okay, this is the number that I'm looking for. Okay. So since it follows empirical rule, I have these numbers. These percentages are fixed. I know those. So it's going to be 34%, and this is going to be 13.5%. So 34% plus 13.5% is actually 5.7. 47.5% of all women have height between 58.4 inches and 64.2 inches. I only know the percentage. Unfortunately, I don't know how many, because I don't know how many people were in that sample.